Alright, I'm really sorry about the squeaky floor, but I decided maybe I'll move over on this side and then I'll just try and work on this side mostly. Maybe I'll have to learn to write with the left hand so that the floor doesn't squeak as much. But okay, so this is one example that completing the square is going to be useful, and I said I was going to do this earlier. It's the intersection of a line and a circle. So if I have the equation of a circle is going to be the equation of a circle is x squared plus y squared is equal to some number, and I'll just say 4 here. And then if I have a line, okay, I don't like being over there. I'm just going to stand here. So a line we know is going to be of the form y is equal to mx plus b. That's slope-intercept form. But I want it to intersect this circle, and this circle has a radius of 2. So if that's 2, and then that's 2, that's my xy plane. That's going to be the circle there. So let's see. Well, I could just take y is equal to x. No, that's too easy. Let's not use that one. Let's say y is equal to 1/2 x plus 1/2. So that's going to give me a line that looks something like that. And it's going to give me an intersection point there, an intersection point there. And so what I can do is I can plug in the equation for the line into my equation for the circle. So x squared plus, and then when I solve it, it'll give me the x coordinates of these points. And then if I wanted to find those x coordinates, I can plug them either into the circle or into the line, because they'll have the same x and y coordinates, because that's what makes it an intersection point. So I'm gonna substitute in the equation for the line into the equation for a circle. It's 1/2 x plus 1/2 squared is equal to 4. Alright, so from here I have to square this term, so that's going to be 1/4 x squared plus 1/2 times 1/2 x, but then times 2, so 1/2 x plus 1/4 is equal to 4. Alright, so I have 1/2 x times 1/2, which is 1/4, but then I have 1/2 times 1/2 x, which is 1/4 x, and I add those together to get 1/2 x. So this is going to be 5/4 x squared plus 1/2 x. And then from here, so I added this term to that term to get 5/4 x. But from here, I'm just going to move all of my all the terms that aren't multiplied by an x or an x squared to the other side, and that's going to give me 15/4 over here. I know that because this is, if I want to have the same denominator, I'll multiply 4 by 4 to get 16/4, and then I'm saying 16/4 minus 1/4 is 15/4. Alright, from here I want to divide everything by 5/4. Maybe this is kind of a complicated example, but if I'm dividing by 5/4, I'm actually multiplying by 4/5. So I can just do that, and that's 15/4. But remember, I'm dividing by 5/4, so I'm multiplying by 4/5. Alright, so if you see how we got from here to here, I multiplied 1/2 by 4/5, which is the exact same as a division by 5/4. So we have x squared plus 4/10, or 2/5 actually. So this is 2/5 x is equal to 3. So 15/4 times 4/5 is just 3. Okay, so now from here I can complete the square. So I want to divide that by 2, which is going to give me 1/5. So I'm going to add 1/5 squared to each side. I was worried I would run out of room, but I think I can manage. That's x plus 1/5 squared on that side, and then that's 1/5 squared is 1/25, and so that's going to be 76 over 5 on that side. I think. I mean over 25. 76 over 25 on that side. Alright, so from here, I can already see that I just take the square root of both sides. So I have plus and minus the square root of 76 divided by 25, and that's x plus 1/5. So my answers, I'm going to have two x answers. I'm going to have two x coordinates that will give me the answers here. One of them is negative 1/5 plus the square root of, well, when we take square roots, we take the square root of the numerator divided by the square root of the denominator. So I know the square root of the denominator is 5, so I can just say plus the square root of 76 divided by 5. Or we could just write this as square root of 76 minus 1 divided by 5. So that's one of my x coordinates. That's one of the x coordinates, and the other x coordinate is going to be x is equal to negative 1/5 minus the square root of 76 divided by 5. Or we could just write it as negative 1 minus the square root of 76 divided by 5. And then from here we can just plug in these numbers into our line and get the y coordinate. I'm not going to do all of that right now just because I'm lazy and I don't really want to spend too much time on completing the square. This is one application of completing the square, the intersection of a line and a circle. And generally you're not going to get like rational numbers here, but I mean you can get some rational numbers, just depends. Yeah, it just depends. I mean, I could pick numbers that would give me rational numbers here, and this may be, or no, it's not. Yeah, you can pick numbers that will give you rational, like pick types of equations here that will give you rational numbers. And maybe I'll do one more video in which, you know, I have something that looks better than this, but that is completing an example of completing the square.